This is Rahul, and today we are going to discuss about the time series case study which we did as part of the IIIT Upgrad data science program. Uh, we were basically given a time series case study. This is basically pertaining to a company known as Global Mart. The Global Mart is a global company which delivers across the globe and deals with all the major product categories. So here is the data set that we are going to that we were provided. So if you can see is there here the data set. It comprises of all the shipment details pertaining to different cities, different segments like consumer, corporate, home office. These are the things, and it ships to different countries. And the sales here, the sales is the dependent variable which we need to predict. So this is basically a this looks to be a typical case of linear regression, but it is actually not. So when we actually plot the graph, we see that in particular months the shipment is very high, and this trend continues for quite a long time. In different parts of the time, we see that in the October months there's some good shipments. Similarly, in December month there's a high sales going on. So that we see that in this particular in the whole case study, we see that it's quite dependent on time. So this is basically looks to be a time series case study. What is time series? It's a series of data points. Now each of these data points has some relevance to its past. The sequence matters. We can like x1 depends on x2, x2 depends on x3, like that. So it's a series of data points. So hence it is a part of a time series case study and not a typical linear regression. In a typical linear regression, the output variable y is totally linearly dependent on its independent variables. So it's basically not a linear regression case study. So in time series case study, we start off in the same usual manner. We load the data sets. We do a lot of computations in the data set. We clean the data set. We draw a graph in it. We divide the data set into two parts, which is known as train and test data. And the train data, we do all the manipulations. We make the model on the train data set. We create, for example, we create the graphs for the first 40 months, and we see how our model is happening on the next 6 months. So this 40 months we have to check, is there any particular trend in it. So in time series, the global trend, there are two concepts known as global trend and it's a local trend. Global trend is something which is happening on a global level. For example, in the months of October and August, the sales are very high. So this trend happens throughout the year, and that is why it's a global trend. The local trend happens in a particular region or in a particular space. So it's local to that region only, or local to that particular time series only. So in this one, we as we make all the manipulations in the data set, we predict it. So if you see here, it all depends on the month and not depends on other parts. So we create and then we forecast it. So we then after that, when we have done with our global prediction and then we have done with the local prediction, we remove these global prediction, the local prediction, and then we are left with a stationary data set. The stationary data is nothing but it's basically a residual data set, which we can see in layman terms, which is known as an absurd data set. It has no relevance. So we can, if we find, we go through it to a series of tests and find whether the particular stationary data set has some relevance. If the stationary data set has no relevance and it's mostly is absurd, which in technical terms we state it as noise, we discard that particular data set. And finally, we check how is our model doing with their different sort of a test. So look here, like in this one, for checking the residuals, we have different tests like ADF test, KPSS test. So we test it whether our whole residual is stationary. So in nutshell, what we do is that we make the whole model, We take out the global predictions, we take out the local predictions, we are left with the stationary part. The stationary part is checked whether it has noise in it. In case it has noise, it is discarded. So this is a part of the whole, this is the whole, in a nutshell, in a layman terms, this is said to be a time series case study. And then the model evaluation is finally done using MAPE. So in MAPE, they are particular in, they are certain in, if they are in, like in technical terms, if it is in 32 to 35, then we are well in control. Else, like in different, if the error is very high, then definitely we have to remodel it. So we have definitely different ways of doing it, and not going into it, but in layman terms, this is basically was a time series case study. Thank you.